All right, in today's lesson, we're going to be adding and subtracting rational expressions, but this time they're unlike monomial denominators. Now, do you remember what monomial means? It means it's only one term. And they're unlike, so it's going to be different than yesterday's. Yesterday's was like denominators, so we didn't have to get the common denominator. Today, we have to. So here's a little note for you. Let's pay attention to this. Don't go too low on the least common denominator. You want to make sure that all the denominators fit into it, okay? And I'll show you what I mean. So here's the plan of attack. We're going to decide what is that least common denominator, make each denominator match it by multiplying it by a fraction times 1. That'll just be a funny looking 1, and I'll demonstrate that. Now the problem is just like what we did yesterday, with the exception that not many of these will factor or reduce at the ends. So here's the plan. Mark it, star it, whatever you need to do to come back to it. Now let's look at our first question. It says, notice the instructions. It says simplify each expression, state any restrictions on the variables. Same process we've been doing. So look at number 1, 7 over x plus 2 over x squared. So I need to give myself a little space, and let's decide what is that common denominator going to be. Now, notice it has to have an x, right? But how many x's? Well, x squared is the smallest that it can be for both of them to work, right? So then I go back and figure out what do I need to multiply each of them by to get at x squared in the denominator? Well, this first one needs another x in the denominator. So what you do to the bottom, you have to do to the top. This is that funny looking 1 I was telling you about. They're equivalent top and bottom. That means it's a 1. So we're all good. The second fraction, I don't really need to multiply by anything because it already has the correct denominator. So 1 over 1 doesn't matter. You don't have to do that. Now let's finish this up. So this will become 7x plus 2 over x squared. And then I look, can I take a GCF out or reduce it in any way? And in this case, I can't. So now let's think about it. What values that x cannot be? What would make this equation undefined? Well, look back at your beginning steps if you need to. What values would make that undefined? Well, it's really just a 0, right? This one's pretty simple, just 0. So this is my answer, 2 parts, right? The simplified expression and the restrictions. Let's look at number 2. 3x plus 4 over 10x plus 8x minus 1 over 3x. All right, so I'm going to give myself a little bit of space here. And let's figure out what does this denominator need to be. Notice, let's do numbers first. 10 and 3, what's the least common denominator between a 10 and a 3? Well, it would be a 30. They both have an x, so let's just put 1x there. Now let's go back to each individual component and figure out what I need to multiply by. Well, to get 10x to 30x, I would need to multiply by 3. So top and bottom, I'm going to multiply by 3. This back one, what do I need to multiply by to get to 30 from 3? A 10. It already has the x, so I don't need an x. So it's just 10 over 10. Now as I go back, it's like I'm distributing backwards, but I am distributing. Okay, so let's do that. Let's clean this up and see what happens. We'll have 9x plus 12 plus 80x minus 10. All right, now let's combine like terms. So 9x plus 80x is 89x. That takes care of those. 12 minus 10 is 2 over 30x. All right, can I reduce anything? It doesn't look like I can reduce the numerator or factor out of the denominator, so I'm good. Now let's think about restrictions. What is it that x cannot equal? What would make the denominator 0? Well, a 0, right? If I plugged in a 0, that would make it divide by 0, and we can't do that, so we say x cannot be 0. Last example. X plus 1 over 3x minus 2x plus 7 over 4x squared. All right, what would be my denominator? Well, least common denominator between 4 and 3 would be a 12. And then with x's, I need an x squared. So go back and think about what you need to multiply by to get that common denominator. Well, I need a 4 and an x. And in the second one, I need to multiply by 3 over 3. Now, I want you to be really careful here. I want you to notice this negative right here. So when I distribute that 3, I'm going to distribute the 3, and I have to distribute the negative. So I need to be really careful here, okay? So let's do the first one. 4x times x is 4x squared. 4x plus times 1 is 4x. All right, I'm going to extend this a little bit. Now, notice this is going to be, if I do the 3 first, I'll have 6x plus 21, right? Then if I distribute the negative, that'll make it minus 6x minus 21. So you can do it in 2 steps, you can do it in 1, but you got to distribute the negative and the 3. Now I combine like terms, so I'll have 4x squared minus 2x minus 21 divided by 12x squared. Now let's think about this. Can I factor that? I don't think I can factor that. I don't think I can reduce it. So the restriction, what is it that's going to make that divide by 0? Well, it would have to be where x is 0. So we cannot equal 0. All right, that's it. That's what you're going to encounter today. So make sure you show your work on what's your least common denominator, and don't forget to do your restrictions. All right, good luck. We'll see you in class.